This video will discuss MGSE7 SP2. Use data from a random sample to draw inferences about a population with an unknown characteristic of interest. Generate multiple samples or simulated samples of the same size to gauge the variation in the estimates or predictions. In 6th grade, students anticipate variability when developing and asking statistical questions. Students understand that a set of data collected to answer a statistical question has a distribution. In 7th grade, students use statistics to gain information about a population. Also in 7th grade, students use data to draw inferences about populations. Students are working on the task Snapshot from the Georgia Department of Education's Mathematics Frameworks. Let's watch as the population is revealed to students. With the reveal, students are able to see that the random sample represents an estimation that is close to the overall representation of the population. How did you all come up with your prediction?
We came up with our prediction by we rarely picked yellow out of the bag, so we put yellow as 5 and then red we picked it only 4 or 5 times, and then we kept picking the blues and the greens out of the bag, so we figured that was the most in the bag.
We got only 3 yellow. 5, 6, 7,
We was close. You were close. Yes, sir. You pulled yellow 4 times.
I got green right.
Okay.
I got green.
Okay, yellow and blue.
With the reveal, students are able to compare their predictions to the actual quantity within the bag. This also begins the conversation around how to use this sample to determine the actual quantity within a population. In the concrete stage of the concrete representational abstract instructional model, each mathematical concept is modeled with concrete materials. In the representational phase, the concrete model transforms into a representational or semi-concrete level, which may involve drawing pictures, using circles, dots, and tallies, or using stamps to imprint pictures for counting. As students transition through the CRA model and begin to work with visual representations like the one seen here, it is necessary for students to continue to conclude the larger the sample, the more representative it is of the actual population. In the problem-solving task, Counting Trees, students work to develop a valid sampling method which is needed when analyzing a given sample of data and drawing inferences. As students work to make predictions for large population sizes, they might use proportional reasoning as a strategy for solving. Other strategies may include using the percent of a sample survey to predict a larger population, or using equivalent ratios to find unknowns.
I was thinking was count all the ones right at the top, then at the side, and then
What do we do?
shouldn't it be the same amount in each one?
I think so, yeah. So if we do just one row and one column, that would be a good sample. So go ahead and circle. What are you trying to do?
You know how, I count this and then that, then we multiply it.
So you're just going to do the first column and the top row? Okay, circle the part that you're going to use, okay? What are you ladies thinking?
We would do the same thing, but then I thought that it would either give you too much, more than there is on the inside, or less than there is on the inside.
Oh, that's a good thought. So what do you think would be a good size sample? So you're thinking their sample is too small?
Yeah.
Yeah. So what would be a nice size sample for this population? Feeling now.
We're trying to figure out how many circles there, because to us, it looks like there's the same amount in each one.
Okay. So if you figure out a fourth, then you can use that to figure out the other 3/4? Mm-hmm. Okay. So how are you going to figure out how many old trees there are in one of your fourths?
We're going to try to count the trees by 5. The old circles by 5.
Well, no. Each circle is one tree. So that's one tree right there. one tree, no tree, because that's a space. Does that make sense? So anywhere you see the white spaces, that means there's no tree.
Okay.
The richness of counting trees requires students to describe and develop an appropriate sampling technique to determine the population of old and young trees. With this task, students have to take into consideration multiple factors, such as the proportion of old trees and young trees, as well as the gaps between them, and also the size of the area used to take the sample. In this Pass the Problem formative assessment, students must first identify the sample size and use it to draw an inference about the number of people who may purchase a pennant. You may notice that as students compute the prediction, cross multiplication was not used. Students are to rely upon number sense and proportional reasoning. Similar to the formative assessment just viewed, Edutopia offers multiple formative assessments that can be implemented within your classroom. For more information on how to implement formative assessments and establishing classroom routines, visit the Georgia Department of Education Mathematics Frameworks course overview.